Now look at this question. Question number 4. The motion of a body of mass 5 kg is shown in the velocity time graph. Right? So there is a body of mass 5 kg and its motion is described by this velocity time graph, as you can see in the figure. Right? On the x-axis we have time, right, in seconds, and on y-axis there is velocity in meter per second. Right? And you can see this, there is a, a line, right? This is the graph. Okay. Which shows the motion of the body having the mass 5 kg, right? Now from this graph, you have to find its acceleration, okay? The force acting on the body and the change in moment of the body in 2 seconds after its start. Getting it? Now, how to do this? So in the first part, as you can see, you have to find the acceleration, right? So when you are given with velocity time graph, what this slope give you? The slope of the graph will tell you what? Can you tell me? The slope of this graph, Anvi, what it tells? Yeah. So see, this is a velocity time graph, right? Velocity and time. If you find out the slope of the velocity time graph, it will give you acceleration. Are you getting that? Okay. What it will give you? It will give you the acceleration. So acceleration is the slope of the velocity time graph. Are you getting that? The acceleration of the body is the slope of the line of velocity time graph. Right? So if you find out the slope of this line, then that is the acceleration. Getting it? Right? How to find the slope? Slope, which gives you acceleration. What is the formula finding the slope? y2 minus y1 upon x2 minus x1. Now, what is y and x? y2, y1 are the two values on y-axis, whatever physical quantity you have taken on the y-axis, and x2 minus x1 means whatever value you are taking, whatever physical quantity you are taking at the x-axis. Are you getting that? That means here, since this is a velocity time graph, this will be v2 minus v1 upon t2 minus t. Is that clear? This will give you the slope. Now you can pick any two values. Okay, right? So if you are picking any two values, like suppose you are picking this is as v2, 5 and 0, right? So this is v2, this is v1. Now the value of time corresponding to v2 will become your t2. This will be t2, and this is your t1. Are you getting that? Okay. So v2 is, if it is 5, right? v2 and v1 we are taking as 0, right? So 5 minus 0. Now time corresponding to when velocity is 5 meter per second. So when velocity is 5 meter per second, the time is 2 seconds, right? So write down 2 here. And when velocity is 0 meter per second, time is also 0. So it is 0, right? So 5 minus 0 means 5 upon 2. Okay, that is 2.5. 2.5 meter per second square. So the slope of a velocity time graph will give you the acceleration. Why acceleration? Because change in velocity with time is what? It is acceleration. Is that clear? So what will be the acceleration here for this motion of the body? That is 2.5 meter per second square. So this is your answer of the first part. Yes. Is that clear to both of you? Yes or no? B part. We have to find the force acting on the body. Now, force acting on the body will be given by force acting on the body is given by, yes, what is the formula for force? Force is mass into acceleration, m into a, by the Newton's second law, right? Mass is already given, right? M is 5 kg. This is given in the question, right? So 5 into acceleration, we have already found it out, 2.5 meter per second square. Getting it? Okay. So 5 kg and 2.5. That will be 12.5 Newton. So what is the force? Force acting on the body is 12.5 Newton. Because whenever there is an acceleration, that means there is some external force. Some force is applied. The forces are unbalanced. Are getting that? Then only acceleration can be there, isn't it? So what is that force which is applied on the body? And that actually gives the acceleration to it. That is 12.5 Newton. Is that clear? C part. In C part, you have to find the change in the momentum, change in the momentum, the body in 2 seconds after start. Start होने के 2 seconds बाद, right? What is the change in the momentum, right? So write down change in momentum is change in momentum. Change in momentum means you have to find delta p, right? Delta p, and delta p is final momentum minus initial momentum, right? Okay, p2 minus p1, yes or no? I've already told this to you. P2 minus p1, right? P2 is final momentum, p1 is initial momentum, right? Final momentum mv, initial momentum mu. So mv minus mu will be the change in the momentum, right? Now, m is same for both of them, right? You can write it as m into v minus u, right? After 2 seconds, what is the velocity? Because we have to find the change after 2 seconds. After 2 seconds, what is the velocity? Final velocity is 5 meter per second. And when and earlier, what is the initial velocity? It is 0, right? So v will be 5 and u will be 0. Is that clear? Okay. So m is 5 kg. So 5 into 5, that is 25 kg meter per second, right? So what is the change in the momentum? 25 kg meter per second. Okay. So this is the change in the momentum of the body in 2 seconds after start. So whatever the velocity it attains after 2 seconds, that will be a final velocity, and initial velocity will be 0, right? So final momentum means m into v minus initial momentum, that is m into u. So in this way, we have got the acceleration, force applied on the body, and change in the momentum after 2 seconds after start. Yes, are you getting this? Yes or no? Please, sir. Okay. So in this question, look at this question number 5. If the engine of the car provides an acceleration of 2 meter per second square to start it from rest, and mass, assuming the mass to be roughly 1000 kg, right? So what is given? So first we will write it down. Acceleration is given, that is 2 meter per second square. Okay. Since it is starting from the rest, initial velocity is 0 meter per second, and mass of the car is 1000 kg. Now, what we have to calculate? In the first part, we have to calculate the force provided by the engine, right? What is the force provided by the engine, right? So as we know that from the Newton's second law of motion, right? By Newton's second law of motion, force is the product of mass and acceleration, right? Mass is already given. Always remember, when you are putting the values within the formula, please check their units. They should be SI units, okay? If they are not in the SI unit, first convert it and then use the formula. So mass is 1000 kg and acceleration of the body is 2 meter per second square. So the force provided by the engine is 2000 kg meter per second square, or you can write it down as 2000 Newton. Okay, kg meter per second square is Newton. So force is 2000 Newton. This is the force provided by the engine, so that it gets the acceleration of 2 meter per second square, right? Now in the second part, we have to find the velocity after 5 seconds. What will be the velocity of the car after 10 seconds, right? If force is 2000 Newton provided by the engine, right? So velocity after 10 seconds, right? So to find this, we need to use first equation of motion, right? So from first equation of motion, what is the first equation of motion? V is equal to u plus at, right? Okay. Now, since initial velocity, it is already given in the question, it is 0, right? Final velocity, we have to find. It is moving with the acceleration 2 meter per second, so it is 2 into t. T means we are finding velocity after 10 seconds, so t is 10 seconds. Are you getting that? Okay. So v is equal to u plus at, u is 0, we have to find. Acceleration is 2 meter per second square and time is 10 seconds, right? So this will be 20 meter per second. So what will be the velocity of the car after 10 seconds? That is 20 meter per second. If it is moving with the velocity of 2 meter per second square, with the acceleration of 2 meter per second square, and the force provided by the engine is 2000, right? So it will attain some velocity after some time, right? So after 10 seconds, its velocity will be 20 meter per second. Now, coming to the third part. In the third part, what you have to find? You have to find time after which the car comes to rest if the engine is turned off after 15 seconds, right? Because engine is providing the force. Now it is turned off after 15 seconds, right? Now we have to tell that after how much time it will come to the rest if the frictional force is 15 Newton, right? So it is coming to the rest because of the frictional force. Yes or no? If there is no friction force, then it will keep on moving according to the which law of Newton?
First law.
Huh?
First law.
First law of Newton, right? So first law of Newton says that if a body is moving, then it keep on moving, and if it is at rest, it will be on rest until and unless external force is applied on it, right? So this frictional force is that external force which is applied in the direction opposite of the motion, and because of this, that car will come to rest after some time. So we have to find out that time. Are you getting that? So what we will do, we will first find out the final velocity of the car after 15 seconds, because engine was working for 15 seconds. So the car attained some velocity. Yes or no? So write down final velocity of the car when the engine is on after 15 seconds. Means after 15 seconds, engine is on, and what will be the velocity it attains? So it is again whether v is equal to u plus at, right? U is 0, acceleration is 2, time is 15. We can easily find the final velocity. It will be 30 meter per second. That means after 15 seconds, it has attained 30 meter per second velocity, right? Okay. Everybody getting that? Now, what you will find now? So tell me how you proceed after this. So since we have found out the velocity attained by the car after 15 seconds, that is 30 meter per second. Are you getting that? Right. Now, what is the momentum? P is equal to m into v, right? Okay. Mass is 1000 kg. Momentum we can find by multiplying 1020, right? Is it clear? Okay. Earlier it was 20. So this is 20,000 kg meter per second, right? Now after 15 seconds, what is happening? After 15 seconds, net force. First, we will find out what are the net forces. Force exerted by the engine, right? Force exerted by engine plus frictional force, right? Net force is always the sum of all the forces, right? Now, force exerted by the engine is 2000 Newton, right? But the frictional force is in the opposite direction. So we will take it as negative, minus 15, right? So what is the net force acting on the body, acting on the car? That is 1985 Newton. Okay. Right? So why we are subtracting the frictional force? Because it opposes the motion. And therefore, we put a negative sign because it is applied in the direction opposite to the motion. Now, can we find acceleration from this force? Yes or no? Acceleration will be F upon A, F upon M, net force upon mass from the second law of motion, right? F is equal to ma, so A is equal to F upon M. Are you getting it? So from here we can find what is the acceleration. 1985 divided by 1000. Getting it? Okay. So this will be 1.985 meter per second square, or approximately 2 meter per second. 2 meter per second square. Is that clear? Okay. Now time. Pardon?
I have a doubt.
Yes, tell me.
Can you scroll up?
So as you can see, net force upon mass, right? This is 1.985 meter per second square. So this is approximately 2 meter per second square. Means in comparison to the force applied by the engine, this friction force is very negligible, right? And we assume that this is actually equal to 2 meter per second square, right? The same which is given in the question, right? But since it is given in the question, so we need to do that, right? Okay. So this is your acceleration. Now, time taken by the car. Comes to rest. This again, we can use V is equal to U plus AT. Now this time this acceleration is the retardation, the negative acceleration, right? So this 2 meter per second square, right? With this, it is actually retarding, right? Okay, so we will take it as use U minus AT, right? So we will take acceleration as negative, right? Okay, so write down U is 30. Initial velocity will be now 30. Final velocity will be 0 because it comes to rest. Okay, minus 2. It is decreasing, right? It is retarding with 2 meter per second square into T. Is that clear? So now T will be equal to 30 by 2. That is 15 seconds. So how much time it will take to stop the car? That is 15 seconds. So are you getting this? Means when engine stops working, it attains some velocity, right? That velocity is 30 meter per second, right? Okay. When the engine stop working, right? Now, this V is 30 meter per second. This becomes your U. अभी आपका initial velocity बन जाएगा. And what will be your final velocity? Final velocity will be 0 because it is coming to rest. So initial velocity 30 meter per second. V will be 0. Acceleration. Now this time this acceleration will be negative acceleration. So we will put a negative sign. This is a retardation. That is 2. Okay. A is minus 2 meter per second square, right? Okay. Because it is applying the brake, or you can say it is retarding. The motion is retarding, right? Now you can easily find the time. Everybody getting that? Yes or no? Please tell.
Ma'am, I have to write the whole answer.